Hi, welcome everyone. Can you hear me? All right, I think everyone's in now. Welcome everyone and good morning. I'm Azlin from SEAS and I'll be your MC for today. Welcome to the 7th edition of the SEAS Expert Series, and today's topic is on update of the solar PV roadmap. We thank you for your support and hope that you will find the discussions today useful. Just some housekeeping rules before we start. We will start with the presentations and answer questions at the end of the session. All your mic will be kept mute, so please use the chat box function and share with us your questions, if any, and we will answer them at the end of the session. Else, you may also use the raise hand function, and our moderator will unmute you to ask the questions directly. I will now invite Ms. Kavita Gandhi, our SEAS Executive Director, to give her welcome remarks. Kavita, please.
Thank you, Azleen. A very warm welcome. Great to see all our participants this morning and some more streaming in. So this is, like Azleen mentioned, 7th in our series of expert series webinars where we bring experts to you. And the idea was that during this period when we were all at home, to stay engaged and informed, not just with our members, but also with our partners and our stakeholders at large. So today's webinar will be about the solar roadmap update. This is a publication that the industry really looks forward to, as it really gives guidance about not just the scale, assess the scale, but also inform the policy, the research and development, and many other areas in the solar space. And I'm delighted to welcome to this webinar Dr. Thomas Reindl from Ceres, who's the Deputy CEO, but not just that, he's a strong supporter of SEAS and our partner in many, many activities that we do. So Thomas, thank you very much for bringing this to us, and I'm sure, like me, most of our participants are also really looking forward to hearing from you about what's new in this space. So over to you, Thomas, and thank you once again.
Thank you very much, Kavita. And it's my great pleasure to be here and to share with you some of our work which we have done over the last 1.5 years in putting this update of the PV roadmap together. I will share my screen and then you can see the slides as well. So as it was mentioned at the beginning, we will have about half an hour. I will run you through the main points and the main topics of the PV roadmap, and then we'll go into the question and answers. And I also saw a lot of familiar faces in the list of participants, and I'm more than happy to share the findings with you. I'm from Ceres, the Solar Energy Research Institute of Singapore, which is Singapore's national research institute for applied solar research. But this was not just a Ceres, we were the lead partner in a consortium together with various departments of NUS, which are listed here, as well as from NTU, because our idea was to really bring all thought leaders together for this exercise. And I would also like to acknowledge our partners, particularly the lead agencies, NCCS, EDB, and EMA, and NATO, which were extremely helpful in the discussions and in shaping the outcome of the PV roadmap. In addition, and that was a bit different to the first PV roadmap, which we did in 2014, we reached out to all relevant government agencies, and you see them listed here, and they gave extremely valuable feedback, and we had very numerous discussions in how to shape and how to push solar forward in a way where it still fits to the overall framework of Singapore. And of course, I want to acknowledge the entire dedicated PV roadmap team without reading every single name, but they were from Ceres, from the various NUS departments, as well as from ARIAN and the Experimental Power Grid Center, EPGC, which during the course of the roadmap has been transferred from A-STAR to ARIAN. The roadmap is not a hidden document. You can find it, it's freely available. You can download it from the series as well as from the NCCS website. And if you have any questions, please feel free to reach out to me or my colleagues, but representative for the entire PV Roadmap Consortium, you may contact me. We have two documents. One is the main technical report, about 85 pages, and then we have an addendum where we thought about the topics of grid mitigation measures for PV, smart grid, IoT. This is more generic, not necessarily at that level broken down to the full application of Singapore, but we thought it would be sad not to share this with the general public, so we put it into an addendum and kept the technical report focused on the needs of Singapore. Now, the structure of the PV roadmap is, as it's shown here. We first give an overview of the global PV market, particularly what has happened since the original roadmap was published in 2014, what are specific Singapore developments, and then we have two main sections. One is an update to topics which we already had covered in the 2014 roadmap, and then new topics which arose over the years from 2014 till today, where we thought it has certain relevance for Singapore going forward. And then we finish with some recommendation, and that's also the structure for the webinar today. But I will jump directly in the interest of time because many of you are familiar with what's happening in the global PV market, what's happening in the Singapore PV market. So we will jump right away into the update of the 2014 roadmap and then also cover new topics and recommendations. Now, for the update, we have 6 topics: space availability being the first, space utilization and increasing energy yield. These are topics which somehow all belong together. Space availability means where shall all the PV systems go which we want to deploy in Singapore. But then also space utilization. What are technologies, novel technologies, which utilize the existing space which we have identified earlier then? How can we maximize the space utilization, but then also increasing the energy yield? So we have to make sure that every kilowatt peak which we have, every kilowatt, I think someone, CN Ong, has started screen sharing. Can I ask CN to stop sharing, because that would affect my sharing, because in Zoom only one person can share. So CN Ong, if you don't mind to stop sharing. Otherwise, I would need the help of admin to allow me to share the screen again. Yes, that looks better. Okay, here we're back. So we also want to increase energy yield. So for every deployed capacity, we also want to maximize energy yield that is generated, so that overall the energy, the solar energy generation, that should be the prime aim to increase total PV electricity. And then we will talk about cost, because cost is obviously a driver in a free electricity market. And then also possible scenarios. We have updated the baseline and accelerated scenario, and then had a much more detailed look into PV grid integration compared to the 2014 version. Now, in terms of space availability, as a first point, we have looked at 5 areas. One being building rooftops, one being building facades. The third one is land-based PV. The fourth one is floating PV. And the fifth one is infrastructure. We call it infrastructure PV, which meaning using existing infrastructure and add solar PV to it. Now, in terms of space, general space availability, we had numerous discussions with various government agencies, and we have to be a bit mindful that there is not only PV out there, there's also other considerations. And as you know, Singapore wants to become a city in a garden. So greening and the environment is definitely something which we need to take into account. And there's a lot of activities going on to green Singapore, also in industrial estates. So that needs to be addressed very particularly. And you see the graph here on the right, which comes also from the agency side, where the trend towards PV is probably more in industrial areas where you have less impact to people's lives and the greenery ambitions. So that's one point. Another one is public acceptance. So this is something which we haven't talked much about in Singapore, because so far the 350 megawatts which we have installed are predominantly on rooftops, and they are hardly seen. And but going forward, if we have more floating PV on reservoirs, or we may overbuild existing infrastructures, then PV will be much more present and visible. And that also needs to be, so we need to over time also enter into a dialogue on general public acceptance. And then of course safety, be it fire safety, be it general safety, when we start talking about overbuilding infrastructures, for example, then safety considerations are of vital importance, of course. Now, in terms of buildings, we have developed as part of this roadmap process a very detailed assessment for every single building, and we had collaborated very extensively with SLA, the Singapore Land Authority, where we got access to the full 3D model, which was not available at the time of the 2014 roadmap, because the first detailed model was being generated as we developed the roadmap, so it was not accessible back then, but we have it now. And so we developed a very detailed process into pixeling individual buildings into certain patches, and then how to find out what are the minimum irradiance thresholds given certain economic considerations. Then also tilt, because you lose with higher tilt, you lose more irradiance. So we filtered out by tilt. We filtered out by minimum surface areas, because if you only can deploy 1 or 2 solar panels, then the mobilization cost will not allow you an economic operation over time. And then we also have looked at different utilization factors, and the utilization factors which we had originally assumed in the 2014 roadmap, we updated them quite substantially, because we figured out that existing installations which have been built since then on particularly HDB roofs and commercial roofs are much utilized the space much less due to other uses, due to say M&E equipment on commercial buildings, or certain tenants have certain rights on rooftops. So the actual deployment area, we learned, or we understood now, was much lower than we originally had planned. But in addition, we found in other spaces where we can deploy almost an equal amount of PV compared to what we had originally assessed. So we had a very detailed process, also very efficient, because we had to do this for the entire building stock, which is more than 100,000, it's 132,000 buildings, which we assessed as part of this roadmap. And as part of this, we are also in the process of doing some visualization. Here you get a screenshot from one of our assessments in the downtown area. What we are currently working with is that we work with some of the government agencies to develop a solar cadastre, so that all the information and all the detailed assessment which we have elaborated in, and you see here this heat map, so to speak, that this will be made available hopefully in the next 6 to 12 months, that this will be made available for potential adopters, for building owners. We want to have a solar cadastre where you can log on and you see your building, you can draw an area where you want to deploy PV, and then get information about what is the potential capacity, what would be necessary investment, what would be the return on investment, and possibly even a list of installation companies where you can buy the system from. So we want to really make this great wealth of information which we generated through this PV roadmap available for the PV industry to really use this as a tool and as a multiplier, so that we get more PV onto existing buildings, be it on the rooftops or facades. Then the third one, what I mentioned, is land-based PV, also mobile in a sense, and you probably know the Solar Land program from JTC, where you see here the picture, the very first one, the 5 megawatt on Jurong Island. So we did quite a detailed assessment of what is the potential for land-based PV. Where are land plots? And Jurong Island is definitely one of the hot areas for that. And there's also a grant call currently out from JTC about what can we do in terms of innovation in Jurong Island. Also Pulau Semakau, which is already part of the REITs testbed, and is a great opportunity for deploying larger scale PV. But also on the main island, we found a lot of free areas, which are probably not entirely free for the next 20 years, as long as you want to run your PV installation. But if it's somewhat mobile, and mobile doesn't mean that we have to dismantle it within a few hours, but if within a given reasonable given time frame, there are many industrial areas which are earmarked for development, but they may not have started, and the development may even happen only in 5 or 10 years from now. Then for those 10 years, you can use this the plot of land and generate PV, and then in 10 years maybe you can move the installation to another plot, which is then in this 10-year time frame. So there's a great opportunity, and this is a sizable amount which we assessed. And then the innovation angle, which is always important to keep in mind, so that we also adapt to the specific situation in Singapore. So we need more movable, mobile, easy to deploy systems, combined then also with mobile substations. And some of the aspects already have been taken into the latest tenders for the Solar Land program. The fourth one is floating PV, and I think you all you are familiar that we have operated this testbed in Tengeh Reservoir since 2016. So Singapore was one of the early adopters, or especially in the research and testing of different types and ways of deploying floating PV in preparation for a larger rollout. And Bedok and Lower Seletar are already in implementation. Tengeh, that's the biggest one at the moment, is being prepared, 60 megawatt, also one smaller one in Upper Pierce. The 60 megawatt today would even be the largest floating PV system outside of China. So we are really on the forefront when it comes to floating PV. And there was also a request for information from EDB about the 100 megawatts in Kranji Reservoir. In addition, Singapore has also started moving offshore or near shore. So Sunseap is currently building this 5 megawatt offshore in Woodlands, which at the moment would also be one of the largest in the world. There's another one, 4 megawatt in the Seychelles, but this is, I think, as of today, as far as we understand, would be one of the largest in the world. So Singapore is really at the forefront for floating PV, and that's also why we are trying to support this and push this from Ceres. It's one of our flagship programs, and we will hold, and I'll show you a slide at the end, the 4th round already of the International Floating Solar Symposium as part of the Singapore International Energy Week and ACES, the Asia Clean Energy Summit, in late October this year. And then the last one is infrastructure PV. This is the idea, and this is probably the one in a timeline which is a bit further down, to say, can we use existing infrastructures and overbuild them, go basically in the 3rd dimension and overbuild them with PV, and this would be for existing land, so which has already a certain purpose, and can we overbuild this for PV, which may even offer some shading if we talk about so-called hard surfaces. like car parks or areas where people would appreciate some shade, but also noise barriers. This is something which has been done in other parts of the world, but not much yet in Singapore. But that also has, with the advent of bifacial technology, where you can put vertical PV system and they generate from both sides, solar power from both sides. We also looked into some of the large flood canals, which are needed for when we have our torrential rainfalls here in the tropics, but even roads, as you see here in animation on the right-hand side. But this is obviously, these infrastructure PV options need a bit more considerations. Our aim was here to really open the minds and really start and trigger a discussion about these topics. Of course, we need to talk about public acceptance, safety, operational issues, particularly when we talk about roads. There's also a big program going on with LTA and NParks for greening of roads and canals. Grid connection is also a topic, because it may not work that you literally plug into the next available lamppost. So there's a lot of considerations, but we wanted to not stop at conventional deployment, because we will always be limited in space, and we have to be quite creative and do a bit out of the box thinking when it comes to deploying PV in Singapore. In summary, and this table is also directly taken out from the PV roadmap document. So we have these 5 deployment types. It's broken down, so the rooftops and facade come directly from this very detailed 3D model assessment. This is based on the 2014 building stock. Currently, SLA is updating the 3D model with the 2019 building stock. So as soon as that is available, we will then rerun the solar potential assessment, and then we can also update these numbers. And that's then always split into HDB, industrial, commercial, as well as others. But also for facades, for building integrated PV, for both retrofit and new buildings. And then you see the numbers for mobile land-based PV, floating PV, as well as infrastructure PV. So overall, we see 36.8 square kilometers of potential space. And this is slightly lower than the 45 square kilometers we had anticipated in the 2014 roadmap, which was more a top-down approach and much less detailed, because we didn't have the underlying models available. But it's arguably somewhat in that range, and the lower numbers are predominantly because we had it in the past a bit overestimated how much could really go on a HDB or a commercial roof. On the other hand, we found a few more areas to compensate for using mobile land-based areas, as well as floating infrastructure. So this is about the range, and this whole assessment was done on square kilometer range or on area, rather than on how much capacity can we deploy, because going forward, PV modules will increase in efficiency, they will increase in yield. And so depending on what area gets deployed at what period in time, from now until 2030 and even 2040, 2050, that will change the capacity. And in order to get out of this dilemma, we kept it entirely here for the assessment of what would be the potential. We kept it here on area base. So this was the space availability. Then space utilization. That means we, of course, for every square meter, you can put different type of PV technologies. What we did then is an assessment of what is the business case for high efficiency technologies. And here we have a graph where we have different technologies from left to right, and then calculated the LCOE over time, over the entire lifetime of a system. And you see that from left to right, which is from standard multi P-type, which is the lowest crystalline silicon technology, lowest efficient technology in the market, all the way to heterojunction and all-back contact, which is the highest technical efficiency which you can get on the market today. And then you see that the red bars are almost flat. So that means the LCOE over time is almost identical for all of these technologies. But the dark red curve goes up, which is the module area factor, because you have much higher area efficiency on the right. And that means, despite the fact that you have a higher initial capex, which you see on the x-axis, you will gain so much more in energy yield and then in revenues that it levels out over time. So if you do a 20 years lifetime assessment, then you get to the same LCOE, whether you have a standard module or a high efficiency module, but you utilize the space much, much better by going to high efficiency technologies. And high efficiency technologies have an additional advantage, which I'll come to in a minute. And then for technology advancements, of course, we have to move into heterojunction and assess all-back contact solar cells. And we are in a good position in Singapore because, at least for heterojunction and back contact cells, the two leading manufacturers are now both headquartered in Singapore, with REC on heterojunction and Maxeon, the former SunPower, for all-back contact solar cells. So this Singapore is in a very good position, and even better position now to push the boundary beyond the 30% range. And for that, you need so-called tandem solar cells, where you add another layer on top of silicon, quite likely, which then absorbs better the blue spectrum, which in turn means we get to beyond the limit of silicon, which is in the 28–29% range. That makes it possible to go beyond 30. And Singapore is again in a very good position because Ceres is an expert in industrial crystalline silicon technology, and Ariane and NTU are very much leading in perovskites. And the combination of both is currently the most promising. There are hundreds and thousands of researchers around the world are hoping to get a breakthrough, and Singapore again is in a very good position. So next generation solar technologies will then move towards higher efficiency. Another area how we can optimize and maximize space utilization, also in the context of urban solar, because we will always be limited by this high densely urban environment. Standardized solutions which increase the deployment is definitely an important topic, but also co-location of PV with greenery. So we are really trying to see, we have done initial research that the cooling of plants has a positive benefit on PV modules. So they are cooler when they are close to plants where you have plant activities and irrigation water. So this is an area which we are pursuing with quite interest now. But also facade integration, building integrated PV, this will be a big thing for Singapore. Obviously, every building has more facade areas than rooftop area, but we need to integrate this smartly into the built environment. And that means we have to get architects on board. We need more colors, more shapes, more aesthetic options. But we're also looking into prefabrication, because prefabrication is more and more prevailing in Singapore. And if you add, as you can see here at the bottom, PV while the system is, or the building is still on ground, and then is built up using Lego type techniques, that is a very elegant way of getting into building integrated PV for new buildings without having to scaffold or retrofit existing buildings. Also, we're looking into ultralight BIPV elements, and even media walls can be PV powered in today's world. Another area for novel applications is mobile and flexible systems. So you may have seen this video from 5B. That's an Australian-based company which has a foldable PV system, all factory made, and you can deploy one set, which is about 35 kilowatts in 10 minutes. It's quite striking. If you have time, look at the video. Very intuitive and would be almost perfect for the idea of having mobile flexible system. but also going offshore or near shore, we probably have more variety, not just putting floating PV on water, but maybe combine it with fish farming, with desalination or other uses for where we can solve, I would say, solve more than one problem for Singapore. Again, urban infrastructure, PV noise barriers, as you see here, I think that will also be a great opportunity for Singapore. So increasing space utilization, novel ideas, high efficiency technology. And high efficiency technology have a very nice side advantage, which adds then on, on another end. If you look at the loss factors of a PV system in Singapore, as circled here in red, the single largest loss factor is temperature, because a PV system in Singapore at full sunshine condition operates about 60 to 70, 60, 65 degrees. And then this negative temperature coefficient of maximum power comes into play. And if you look at the list here of different technologies, then you see that the high efficiency technology, N-type mono-PERT or N-type heterojunction, also have a significantly lower temperature, negative temperature coefficient. That means at the same operating temperature, they still generate more energy and more yield. So the high efficiency technologies not only help us in increasing the space maximization, but also in generating more energy yield. And this is definitely an important way forward for Singapore. Another area which we looked at, and this is described in more detail, is also how to operate the highly distributed fleet of PV systems. And we're talking about thousands of HDB roofs, for example. You don't have the luxury of having hundreds or 200 megawatt solar farms. So the 60 megawatt in floating PV in Tenge is probably really an exception. And hopefully we'll see more of those in Semakau or in Jurong Island, or one day maybe in Kranji. But then predictive, preventive maintenance, you cannot always send out personnel to every single rooftop if you want to see how the system is operating. So we need more condition monitoring, non-invasive diagnostics. And I think AI-based technologies, Singapore is also in a very good position to push boundaries here. Now the question is, when we know how much space is available, how we maximize the space and increase energy yield, at the end of the day, someone has to pick up the bill, and we have to see how the economics work out, because obviously there's many more people who want to make money rather than just saving the planet. So we need a combination of both. And we have described in the roadmap, and you probably have seen this list, this merit order list. So the lowest possible way of generating solar electricity today would be large ground-mounted PV, which is the largest, where the learning curve has gone furthest all around the world. And this can be done for about 6.5 to 7 cents, I would say, in Singapore today. And then you see the different options for large rooftop, medium, floating. And then we also try to assess and project this. How would this look like 2030 and 2050? So we are moving into the 4 and below 4 cent, and this is all Singapore cents per kilowatt hour range for the lowest cost of electricity. And this is definitely then also comparable with conventional generation and also competitive. In terms of possible scenarios, we have updated the 2 scenarios. One is a baseline scenario and one is an accelerated scenario. The baseline is with a lower adoption rate for the different space availabilities, mostly led by government projects, HDB, SolarNova, floating PV, and then also an evolutionary rather than a revolutionary adoption of high efficiency technology. I would say the baseline scenario is basically, if we don't do anything, this will happen anyway. So we will get to a certain amount of installations just because it's economically viable. There are certain SolarNova programs. We run a few more SolarNova programs, and then the baseline program is already in the pocket, basically. For the accelerated, we have a much higher adoption rate, and there we need much more engagement from the private sector, industrial application. We also need novel applications, nearshore floating, mobile land, BIPV, and then have a much higher use of high efficiency technology. And in terms of numbers of installed capacity for the 2030 timeframe, the baseline we see it at 1 gigawatt. This is what I said, if we do nothing, we have already 350. If we continue what we have done the last few years, we will get to 1 gigawatt by not much adding additional activities. But if we want to really achieve the goal of more than 2 gigawatts by 2030, and we have set the accelerated scenario at 2.5 gigawatts, then we need all these points, which we need a stronger adoption of novel technologies. We need a strong engagement of the private sector. And projecting it for 2050, we are looking at 2.5 gigawatts in the baseline, but 5 gigawatts, and this is the more likely then for the accelerated scenario, which then gives us certain PV penetration levels. Here it's the penetration level at midday, the really on power level, not on energy level, on power level during midday. And then we have a certain set of electricity contribution and CO2 emission savings throughout the year. For PV grid integration, we have done a very detailed study, because this is obviously of a great concern, because if we have these rather high, say 30 or 40 plus % on power level, then the high variability from PV really can make an impact. And so we did a global study of what happens in those countries which have the most penetration with variable renewable, not only solar, but also wind. And then so we looked at Japan, Germany, Hawaii. Hawaii is probably the one which is most comparable to Singapore. And then also Australia and California. And there's common challenges are those listed here, A, B, C, D. One is the demand profile and ramp rates. One is the distribution network impact, because you have much more generation, variable generation on the distribution side. One is inertia and reserve requirements, and the fourth one is protection system. And then we played with different scenarios, and the typical mitigation measures are then described in the addendum, which is supply and demand, storage, grid upgradation, but also new equipment, including solid state transformers, for example, which is one of the research topics where Singapore is also quite a bit in the lead. So without going into details, this is just a comparison. You know, the famous duck curve in California. If we look at the scenarios for 2030 and 2050, then we see that our duck doesn't have a head, but we do still have ramp rates. For 2030, the ramp rates are okay, but for 2050, we probably have to look into ways of how to mitigate, and we have to carefully observe and see how the entire generation portfolio is set up so that we are able to manage the then much higher ramp rates. For other areas, be it the distribution network impact, voltage, frequency, protection system, we didn't see any major impact. So this is all manageable, even for the accelerated 2050 scenario. So this was a bit the update, the main part of the roadmap. I just browse a bit through the new topics. One is PV recycling. This is now not for Singapore, but a general framework. Of course, after 20 years or 25 years, many of the PV panels will come back. And then the question is what to do with it. And this end of life, currently is only about 10% are actually recycled. Many of them end up on garbage deposits. So we are trying to also, we also wanted to sensitize the industry, what would be a way forward. And Singapore is obviously a rather small market given our limited space. So we have the global world market is 100 gigawatt every year now, and we have 350 megawatt installed. We go to more than 2 gigawatt by 2030. So Singapore alone will not be able to solve the recycling problem, which is more a global problem rather than a Singapore problem. But it doesn't hurt to sensitize the industry and think of ways what we can do, and opportunities would lay in on-site recycling, because very often the transport, probably not so much in Singapore, but in other countries where PV systems are in remote areas, the sheer transport to a central recycling facility is typically more expensive than the raw value of what you get out of the materials. And then the economics obviously doesn't work out nicely. Currently, the only jurisdiction where it works reasonably well is the EU, the European Union, because they force every manufacturer to pay a token into a central pool. And that probably is a good way, we will see, to make sure that systems don't end up in large waste deposits. But also cost-effective, less energy-intense recycling solution or circular economy are ways going forward where there's a great potential for opportunities. Renewable energy certificates, that's something that also popped up in the last 5-6 years. And there's two types. One is bundled, where you sell the green attributes together with the electricity, or unbundled, where you sell only the green attributes. And there's already an industry with 6 registries or players in Singapore. And currently there's an activity between SEAS, NEA, and a whole group of industry representatives to define Singapore standards for renewable energy certificates in order to fulfill the demand, which is mostly from the RE100 and SGX listed company, but as well as those who want to have more sustainability in their operations. A last topic, which was a bit beyond the scope of the roadmap, is importing. I don't go into details here, but you know about the Pan-Asian supergrid, which has been discussed over decades. That would be one way to tap into other sources. We also looked at land-based direct cable connections from our immediate neighbors. Offshore floating may be a topic one day. There's big activities going on, particularly in Europe, in Holland and Belgium. There are consortium who look into can we use the spaces between wind farms and power and use large-scale floating solar offshore and use the infrastructure which has been laid for the wind farm and piggyback on that. So interesting concept, but we don't have these large wind farms here nearby, but you never know. We have looked into 20, 30, 40, 50, maybe one day it would be an opportunity. And of course, the last point here, you probably have heard about Sun Cable. They have done quite a detailed study on whether it's worthwhile laying a cable all the way from Australia, which would be the largest length for overseas cable anywhere in the world. We have yet to see where this materialized, but I've been in contact with Sun Cable and they have a very serious approach to it and have done very detailed studies. So we will see how this works out and also from a techno and economic perspective. And then of course, from importing energy, we can also move further away from just importing electricity, but using power, so-called solar fuels, from power to gas, power to fuel, which would either be hydrogen or even chemical feedstocks from reducing CO2. And Australia is positioning itself at the moment as a renewable or as an exporter of renewable energy in different formats, and renewable hydrogen is one of the most sought after ideas there. And here are 2 areas listed which have done quite a bit of planning and obtained quite a bit of funding, be it the Asian Renewable Energy Hub or renewable hydrogen, which wants to export hydrogen in form of ammonia. But this was beyond the scope. We just briefly touched on it. I want to mention here that the same lead agencies are currently conducting a study on hydrogen. What would be a future hydrogen economy in Singapore? How could it look like, and what would be the benefits? And I think that will be available then also later in the year. Now, just to summarize some of the recommendations which are also taken from the roadmap. So again, high efficiency technology, there's a huge opportunity. We have top players in Singapore, industrial players. We have top research organizations. So I think there's a huge opportunity there. But also from a policy perspective, I think future government tenders should specify more higher efficient systems and also more energy yield and higher performance ratios in order to ensure that the space maximization and increase of energy yield from the limited amount of space we have is really seen and implemented in the real world. Novel urban solar applications, I talked about standardized or plug-and-play solutions, co-location with greenery, BIPV, huge opportunity for Singapore, mobile land-based system, floating infrastructure. I think there's a lot of novelty that can come out of this. And specifically for Singapore, and we always looked at technologies which help us in Singapore, but also would be exportable and can be commercialized out of Singapore into other mega cities, be it in Asia or elsewhere in the world. And then also for policy and regulations, we always we try to implant this seed that urban planning is done with PV in mind, to have more areas available for PV, solar-ready roofs, as HDB is already doing it, open infrastructure for test bedding, at least for noise barriers, for JTC is doing basically opening up whole of Jurong Island in the current RFI. And then we also want to look into the built environment. Probably we need more encouragement, the Green Mark scheme, and our BIPV Center of Excellence has even proposed a solar architecture award, which probably going forward we want to nurture this, that this will be awarded maybe once a year or so. For grid integration, I mentioned we have the different mitigation measures. They are detailed in the addendum. Also forecasting will become a part of the operational system at EMA. There's great opportunities for demand response, energy storage, virtual power plants. I think there's a lot of activities already going on. For policy and regulations, we probably need to look over time into a capacity-based energy market system, because the high level of variability from solar need to be somewhat backed up by standby reserves, and they need to be priced accordingly. And over time, we may look into shortening of the dispatch cycle of today 30 minutes to maybe lower numbers in order to mitigate the impacts of the high variability from PV with increasing share of PV. And then additional topics which come up, recycling, circular economy, I mentioned that. Two more topics which are also mentioned in the roadmap. One is and that's a big question for some of the urban planning and some of the planners and lead government agencies like URA, MND, BCA, HDB. What is the impact of many solar panels if we have gigawatts of PV on the urban heat island effect? And the literature is not clear about it, and I think we need to look at it from specifically for a Singapore perspective. And I know that some activities are already ongoing in this space. And we also propose some possibilities of increasing bankability for PV, because the electricity has to be sold into the open electricity market. So you inherently have merchant risk. And the recent drop in oil prices was not very helpful in this sense. So we probably could look into CFD schemes or apply financial models which are a bit out of the box. So we looked at some of the models in the US, where the entire property stock is based as a collateral or used as a collateral. So we just wanted to trigger some ideas which we have seen elsewhere and could well be applied to Singapore. So I will stop here so that we have still a bit of time for question and answers. As I said earlier, the roadmap is available. You can also drop me questions after this webinar at any time. And as I mentioned during the floating PV section, I don't want to leave without mentioning that that we are partnering again with SEAS and ACES for the 4th edition of the International Floating Solar Symposium, which will be held end of October, again as part of SEW in Marina Bay Sands. It is a physical conference, and it probably will have some hybrid elements of pre-recorded or live talks from other parts of the world due to the COVID-19 situation. But do make sure that you register if you're interested in floating solar. With that, I thank you very much for your attention, and I'm very much looking forward to the questions now. And I think I will stop sharing now so that the admin can flash the Q&A part. And so I'm curious to see the questions, or you can also raise your hand and ask questions then. And then the admin will unmute you for your question.
Thank you, Dr. Randall. Please do share your questions in the chat box or raise your hands if you have any questions. My colleagues will help to unmute you so that you can ask the questions directly. In the meantime, there are also some questions in the chat box. Thomas?
Okay, I'll start with the one on anti-glare. The first one is anti-glare technology. So every solar panel today already comes with an anti-reflective coating, because every photon which does not reach the solar cell cannot be converted into electricity. So there are techniques which are now already standard on every solar module. There's an anti-reflective coating which makes sure that more sunlight goes into the solar cell in order to convert it to electricity. And in general, the transmissivity of solar glass is about 92 to 94%, which is much higher than any conventional window glass. And so the glare of a conventional solar panel is quite a bit lower than conventional window glass. Of course, it could sometimes happen at some time, if you have a rooftop installation where the roof is a bit lower than another building next door. There could be some times of the year in some parts of for some parts of the day where you may have some glare, but this should not be a nuisance. It can be, because we are so close to the equator, you can mitigate it by changing the azimuth, just shift it a little bit to the side, and then you can also manage this. But we have done a lot of glare studies also for systems in and around Changi Airport, and in most cases it was not even an impact for flight path or the tower. The next question is canopy-like structures. Yeah, the canopy, so there's for combining PV and greenery, there are two types. One is shrubs, which can be grown, and then PV would be very close on top of it. This is basically just to combine PV and greenery, so you have more greenery on one hand and you get the cooling effect of the PV module. That only works until a certain distance. So if the PV module is, say, raised up a meter or higher, then the cooling effect from the shrubs, which is like a green layer on the rooftop, would not be there anymore. If you combine it, then that's one thing. And the other one is like combining it with like roof gardens, or there's even on ground mounted, you can even have agro PV where you grow maybe usable plants and then have PV on top. But then the impact is more double use of the same area, but you wouldn't have the cooling effect. The cooling effect, at least in an initial study, and we're currently doing a test bed, planning a larger test bed, the cooling effect was 2% energy yield increase per year in a PhD, which was done a few years ago. So this cooling effect is actually quite interesting because you combine the best of two worlds by having a green layer combined with PV. But this would only be, say, functional, but not aesthetically. So you would not be able to use this as a green or roof garden. And so the greenery would be below the PV. Then the influence factors of PR, yeah, that was shown. There's a lot of influence factors of PR. That's your tilt angle, your orientation. Although the tilt angle is less critical in Singapore because we are so close to the equator, you would rather keep it at 5 to 10 degrees so you get a cleaning effect from the rain showers, from the daily rain showers. But the main impact is still temperature. So the more you allow the system to have a natural ventilation, the better your performance is. So we had the highest system temperature we ever measured in Singapore was 79 degrees. And that was a system that was glued on a metal roof. So the metal roof heated up so badly so that at the same time, the PV module heated up equally bad. And therefore the system was extremely high. And if you can operate it at say 50 degrees instead of 70 or more, then this goes directly in your bottom line, because you just generate for the same capacity, you simply generate more electricity. So cooling, good ventilation is the most important one. And then, as I said earlier, certain PV technologies, even if they are still crystalline silicon types, they have a much lower negative temperature coefficient. And that's also the way we built many years ago, 7 years ago, we built a 90% performance ratio system. And that system also used heterojunction technology, because it has such a suitable or favorable negative temperature coefficient. Then there's one question: efficiency so drop at higher temperatures. Yes, correct. Is near the equator. Is this an issue optimizing solar panels? Yes, temperature is, as I said, the single largest loss factor for PV. So good ventilation is key. And even if you do a roof parallel system, say on a rooftop where you use clips, make sure that you have a bit of a height so that even underneath the panels, there's a certain level of air circulation to make sure that the panels cool. Urban vertical farming powered by renewables. Yes, this is something we also have been working on quite a bit now. And there are two ways of it. One is urban farming using containers or greenhouses, which can be done in a distributed fashion. And we are working with one of the local startup companies where we also look into a novel way of cooling system for the urban farm if it's in a container. Because if it's in a container, your main source of heat is, if it's properly insulated, your main source of heat is then the LEDs, which actually provide the light for plant growth. And we have developed some novel concepts for that, which is then also PV powered. So that's one thing. Another one is for greenhouses. There are now technologies available where a good chunk of the visible light can go through, and the ultraviolet and the infrared part are reflected to the frame of the window and then converted into electricity. This has a much lower area efficiency, of course, but it would allow some level of PV generation while most of the light goes through into the greenhouse. And then the third one is then this classic agro PV, where PV could be combined with conventional agricultural activities, and we are looking into that. There's still one agricultural area in Singapore, and we are test bedding probably soon some of these concepts, which have been proven very valuable in other parts of the world. And so but eventually the classic agro PV, there's not enough space in Singapore. So I think there's more opportunities when it comes to more urban concept, meaning containerized or vertical farming, where you have less footprint and yet generate both PV and agricultural products. Then there's a question: what's the recommended space between PV panels and roof deck to minimize the temperature effect? Yeah, that depends a little bit on, if you have a concrete roof, it's typically about 0.5 meter to 1 meter. I think in our 90% system, we have a bit more than 1 meter, so we have very good ventilation. It depends also a little bit then on your tilt angle and on the structural loading for winds, because that eventually determines then your footprint on for concrete slabs to keep the system in place. If it's a metal roof and you do a roof parallel installation, yeah, it would be the higher the better. There's also structural limitations from wind loading. So it's mostly limited by the structural integrity of the roof and how much of the additional weight can be induced into the rooftop through the clips, which then hold the PV system in place. So it's more case by case, but the more the merrier. That's generally always a good way. Installing PV panels along above ground MRT tracks. Yes, this one we have been looking. This is something which we have been looking already in the 2014 roadmaps. I was a bit advocate of that because it helps not only generating PV, but it technically also reduces the sunshine and the heat intake into the carriage. So you would need less air conditioning in the train itself. The limitations come more from safety aspects in case there are accidents or people need to be rescued. And that needs to be taken into very careful considerations. Also access for SCDF for rescue or if there's any fires. So we have looked at that, but we need to revisit this in much greater detail. I think along MRT tracks to put noise barriers or replace noise barriers or put PV noise barriers instead of a conventional noise barrier, that's easier than overbuilding the MRT tracks. And again, it's mostly due to access in case of emergencies. Then PV system temperature. Can a simple water-based heat exchange be incorporated where the heat water can be directly used for bathing? Yes, this is called a so-called PVT, PV thermal systems. So those are also commercially available. They have the benefit of cooling the PV, and at the same time, you obviously get hot water. We tested it quite extensively a few years back in NUS, also for residential use. The tricky part is it makes sense if you have an immediate use of the hot water. And we ran around town quite a bit, and there's not many industries which have an immediate use of the hot water. For private sector, it's very difficult because the generation pattern, which is then during the day, and the usage pattern of the hot water in a residential setting, which is then in the evening when people take a shower or the next morning, in a residential setting, it creates a huge amount of hot water storage where we typically don't have the space available for. So it would be more industrial uses where you have process heat. We have looked into pharmaceutical, food and beverage industry, laundries, hotels. There are certain pockets where it possibly makes sense, but unfortunately not at a scale where it would save us the day. What is the total identified space in floodplains for solar installations? Well, we don't really have floodplains per se. So we have identified a larger amount of nearshore spaces. Unfortunately, we looked at the high resolution CMAP of Singapore as well, but the space is very congested, and the new port in Tuas will have more than double the capacity than our existing ports. So the areas which I was eyed on for mooring and anchoring of ships will rather increase than decrease by shifting the harbor. So it's mostly nearshore installations. We have identified quite a significant amount, and the number was given in the total amount for floating solar. So there are sizable amounts, and JTC is proactively looking into that, and also has earmarked certain areas for testing as part of the current Jurong Island RFI. Okay, so I think I get a hint that we have one last question. What is the total identified? Yeah, that was the one, the last one. So I think we have looked into nearshore spaces rather than clear offshore, because offshore, when we go offshore, you have so much more challenges. You have much higher waves. You have so much more difficulties in mooring and anchoring, possibly even securing the site in this high shipping traffic, given the high shipping traffic which we have in and around Singapore. So we are more looking into what we call dead sea spaces, which are areas behind a marine installation, say a docking station for big oil tankers. And that has to be a few hundred meters into the sea to make sure that this fellow can dock on safely. But then behind this area is typically not usable anymore for any other marine application. That's then what we call dead sea spaces for other uses, but they are perfect for solar because they're somewhat sheltered. They can be used, they're close to shore, so your evacuation line would also be shorter. And so I think there's a huge opportunity for nearshore, be it fixed installation, and also Sanjay's question, to have it floating for harbor crafts. That's definitely also an opportunity. And I think that's also something which Sembcorp has been already looking into, and I think Keppel with a new floating testbed is also looking into that. So for floating offshore, we can really leverage the existing knowledge and know-how which we have here in our marine and offshore industry here. And I think there's great opportunity. And this brings us back to our floating solar symposium. So we have a dedicated session on offshore floating and marine grade floating solar systems. And all these novel applications would be discussed there.
All right, I think we have come to the end of the session. If you do have any questions for Dr. Randall, we will be able to collate them and share it with him. And we will try to upload the answers on the webinar link on our SEAS website. So I hope you'll take a minute to answer some of the poll questions that are showing on your screen right now. Thank you so much, Thomas.
Sure, of course.
We will also upload the PowerPoint as well as the recording of this session on the website, so please do keep a lookout. Again, as mentioned, if you have any questions, let us know. You can send it to our admin account, admin@seas.org.sg, and we will try to answer them for you. All right, a few more seconds to end the poll. Thank you so much for participating, and we do hope that you keep a lookout for our next session next week, same time, same day. We will send out an invite for that, and I hope to see you join us then again. Thank you.
Thank you, Thomas. Just wanted to thank you again. That was wonderful, insightful. I learned a lot, and we hope we'll carry on these conversations further. Thank you.
Of course, anytime. Thank you very much.
Thank you.
Thank you.
Thank you.
And thank you to all our participants as well. We had a great turnout today.
Okay, thanks, and stay safe and healthy.
Thank you, Thomas. Thank you.
Thanks.
Thanks.